What did you get your degree or whatever in?
So I studied theoretical physics.
Okay.
I went to MIT for undergraduate studies, and then I went to UCLA for my PhD
Theoretical physics.
in theoretical physics.
Okay, cool.
Yes.
And then what are you studying at what's the name of your company again?
Quantum gravity research.
Quantum gravity research. So you spend your time researching quantum gravity.
Yeah. So we're trying to figure out ultimately how to unify fundamental physics with consciousness eventually, but maybe leading up to that, we're going to look at the fundamental forces of nature. So that's one of the things that I'm interested in. Mm-hmm. We look into extra-dimensional geometry at quantum gravity research.
What is extra-dimensional geometry?
Okay, well, dimensions are really just numbers. So if you look at space around us, there's a coordinate, and it's just 3 numbers, your X, Y, Z position. Right. And then extra dimensions are just extra numbers. So Einstein's relativity unified space and time. So now we have this 4-dimensional space-time. And there, the geometry was a little different because time is a little bit different than space, but still, you can look at it as an extra dimension. But you can keep on going. I mean, you can go to extra dimensions mathematically. It's certainly well-defined to talk about an arbitrary number of dimensions. Mm-hmm. And so that's something that physicists have been exploring.
And what is quantum gravity?
So quantum gravity is basically trying to figure out what is the high energy theory of gravity. So we know that general relativity from Einstein is a pretty good theory of gravity that describes a lot of things, especially at lower energies. And when I say lower energies, I still mean very high energies for human terms, astrophysical processes. And then there's this other theory of quantum mechanics, which typically describes how really microscopic things work, say at the atomic scale. And we know that, we don't really feel a gravitational force between you and me. It's really relevant for the planets because gravity is such a weak force. So it's been a really challenge to figure out what experiments can we do that merge the small and the big, where we can actually measure something. And so there are certain types of phenomena that you'd expect would come into play for both the gravity aspects and the quantum aspects. So there should be some theory of quantum gravity that can describe all scales.
All scales?
From the small to the large, from the atomic scale to the stars.
Okay. So something that is basically the same, like relatively the same from each side, like from the smallest possible atom to the size of a star.
Yeah,
like
essentially.
An equation that fits both things.
Exactly.
That's what you're talking about.
Exactly. So we have some equations in quantum mechanics that are really good for figuring out how computers work. And then we have astrophysics collecting all the data from how the planets rotate around the stars, how there's galaxies, all of this. Then we have general relativity for that. But there's kind of issues. You can treat general relativity and attempt to quantize it, but for whatever reason, that has been challenging.
How old are you?
I am 33 years old.
33 years old. What made you want to be a quantum physicist?
Well, let's see. It started out, I always had a skill in mathematics, and then I wasn't really that passionate about learning. I ended up doing this summer minority program at MIT in high school, and I just had a really good teacher who taught me wave mechanics in high school, which required all these differential equations and calculus, like advanced calculus. And so I was just exposed to all this difficulty. And I was just surprised to realize that while I wasn't a straight A student in high school, when things got harder, I tended to not get that much worse. So I guess I was just attracted to the complexity of physics eventually, just because it's typically pretty complicated. So. And I just realized I was a little kind of good at it, and I started looking at the classes. I wasn't sure if I wanted to be an engineer or go into computer science, but I was just fascinated to learn about all these different physics things, from quantum mechanics, thermodynamics, general relativity, all these different things. They just looked interesting to me, so I figured, why not?
And you went and you studied this at MIT for how long?
4 years of undergraduate.
4 years of undergrad at MIT, and then you went to UCLA?
Yeah. Yep. So that was about 6 years.
Wow.
So about 10 years of study dedicated to that.
So what sort of like outside influences were there for you to get into this? Why were you so interested in it? Just you were interested in the complexity of it and just the difficulty of solving some of these problems, or what?
Yeah, also eventually I just thought, well, how can I help humanity as well? And I just thought about, it just seems like the natural progression. I think really it's all about trying to maximize our freedom. And to me, I think good technology is meant to make us more free. It can have negative aspects as well. Like anything, nothing's purely good or purely bad, but there's just a natural flow between science to engineering to technology. And I think the goal is, how do we maximize our own free will? And I think that science can help with that. And so I was just trying to think about how can I help the world the most, and what would be enjoyable to me, and how do I balance those things? And just thought it seems like a good shot. You know, it was something where I felt like I could get a job, yet it was a balance of being interesting, yet maybe I could find a job.
And so at your lab, what specific problems are you guys trying to solve?
Well, right now we're trying to figure out how to come up with simulations in a computer that accurately model our world. So we're trying to essentially reproduce on the computer with code, just try to figure out if there's little games that we can make that have really simple rules that get close to what we see in our reality.
Like, can you give me an example of that?
Well, I mean, for instance, you could consider particles, like particle scattering or something like that. So, I mean, the Large Hadron Collider, the LHC, that's one of the largest experiments. I mean, they do proton-proton collisions. And so that when the protons interact, they actually interact with the quantum vacuum, which opens up to all of the particles in the universe, actually. So it's really bizarre. This quantum vacuum has the potential of all of the other particles. So when you do these high energy collisions, it opens up different particles, and it allows for different conversions. Like you can have different particles turn into other particles, or certain particles might get created that are short-lived and then decay, and then we see what decays after that. So one thing we're working to prepare towards is, okay, can we set up the simulations to try to see, okay, if we're modeling a particle as this type of object with the geometry that we have, is there a way that we can eventually hook it up and get those simulations to match the experimental data?
How many people like you are looking at this kind of stuff and spending their time researching this kind of stuff?
Well, quantum gravity in general?
Yeah.
I don't know, maybe like 1,000 or so. I mean, there's a lot of scientists in the world. You know. Didn't
you say that when you were applying for graduate schools, you had a lot of trouble?
Yeah, it's a very competitive environment. So first, there's kind of filters. First, you get into undergrad. So like you might get into a good school, you might get into a worse school. The better school you get in, the higher chance you have of getting to the next level.
Right.
And then there's graduate school, and then you have to become a postdoc. And so you're not a professor yet. You're still making maybe a little bit better salary than a graduate student, but not a great salary. You're in your late 20s or 30s at this point. You know, maybe you're married, maybe you're not, right? And you have to become a postdoc. And that's usually like a 2-year assignment. And you'll have to do a couple postdocs. I was told that I had to go to Europe to get a job to stay in academia. That's what my advisor told me.
Really?
He said it's so competitive, and because UCLA, it's a good school, but it's not like Stanford, MIT, Harvard, Princeton. He was like, chances of you getting a job at the next level, you're probably going to have to go to Europe just to stay in the game.
Really?
Yeah. So it gets competitive. And then, I mean, I have a friend or a collaborator and friend he's published like 150 papers, and he's had like 5 postdocs, and he's probably 10 years older than me, and he's still trying to figure out how to get a professor. And he's published with some of the top experts in his field and has more papers published than some professors, but things are just getting so advanced. There's so many subfields within subfields that honestly, we can't keep track of all the progress that's happening, which really excites me, actually.
It seems like it's makes it confusing when there's so many different subfields and so many different categories where people aren't sort of like paying attention to all of it. It's all sort of like siloed or compartmentalized.
Yeah, so there's also interdisciplinary study, so that does happen. So obviously you can imagine that there's a lot of low-hanging fruit when you combine 2 different subfields and try to find the connection between them. So that is getting more and more popular as time goes by, and even in going out of physics, even so, there's like biophysics, or even chemistry uses a lot of physics. So especially when you get into quantum chemistry. So
chemistry. Wow.
Yeah, at the end of the day, all of chemistry relates to atoms and molecules, and that gets down to quantum mechanics. To really describe what is happening, it's more or less described by quantum mechanics.
And quantum mechanics, correct me if I'm wrong, quantum mechanics is basically like a flower. That's quantum mechanics, right?
Maybe that's one way.
That's how Michio Kaku described it. That's how basically I understand it. He's like, flowers and plants is like, those things are all quantum mechanical.
Okay, sure. I mean, I wouldn't describe quantum mechanics as a flower, but yeah, he can get a little poetic at times.
Yeah. So how would you describe it, like in its most basic form?
Well, it's actually embracing this notion of probability and possibility. So in classical physics, we think of kind of this static reality, like you and me, we're definitely here 100%. And, you know, the system might evolve over time, but it's always well defined. And quantum mechanics allows for this bizarre thing called superposition. And so you can be in a superposition of two different states or an infinite number of states. And so you can have in a single moment multiple states coexisting at the same time. And so that's why you have things like the Schrödinger cat paradox, where you put a cat in a box and let's say you have some poison that's connected to a timer, and you don't know when the timer is going to go off and release the poison. The quantum theory predicts that the cat could be 50% alive or dead. There could be a probability, but we're not sure if quantum mechanics is actually stating the true state of reality, or if it's just a tool to model reality based on the information we have. So, right, like you could imagine there's this cat in this box. You don't know. Let's say there's a 50% chance that the poison gets released in an hour.
Okay.
And you wait an hour. In your mind, is the cat alive or dead? You don't know. You haven't opened the box to look, assuming you can't hear if it's meowing, right?
Right.
So logically, if you know how that poison is released, I mean, just from a logical perspective, you could say that you could just create a tool and say, what's my best chances of getting this right? You know, it's 50% of the time, the cat's alive, 50% dead. So, the cat could just actually be alive or dead in reality inside that box, but it could just be this mathematical tool that helps us evaluate how to assess different probabilities. That's one way to look at it. Other people are saying, well, maybe quantum mechanics is the final theory. Maybe reality is actually like this. Maybe the cat literally is alive and dead at the same time. So that's when it gets into all these paradoxical things and people are like, oh, quantum mechanics makes no sense. I tend to just look at it as a tool. Science is always improving, so I'm not going to assume that quantum mechanics is the final theory. I have no idea what reality is actually like, but I mean, it seems that for the experiments we do, quantum mechanics does a good job of describing those experiments, such as a flower, maybe. I mean, but then again, no one's actually calculating the exact solution of how a flower operates in quantum mechanics. It's way too complicated. So really, you'll learn things just hydrogen atom, like one electron going around a single proton. And even using quantum mechanics to accurately describe large atoms is very challenging. So then eventually you have approximation methods. So it's, we have this theory that can describe how things work, but reality is so complex, we can never find all of the exact solutions to these theories. So at that point, yes, we could say quantum mechanics is describing a flower, but it's actually not that useful for us to describe a flower, because to actually solve how a flower works in the theory of quantum mechanics is way too complicated to do it exactly. But it's still a framework, and it is influencing how we perceive the world. And I think it is a step in the right direction, but maybe it's not the final theory.
How much like internal strife is there in science and academia with people that are like developing theories or like analyzing new theories, and people that are stuck to them and think like, I got it, I got the goal, I got the silver bullet? Yeah,
I would say it's very much just like human culture. We like to think that science is
just
separate.
Like egos and competition.
At the end of the day, there's always politics, there's always humans involved.
Yeah.
However, when you compare academia to the business world, one difference is in business, everyone agrees that you care about making money, right? So you can kind of put your ego aside a little bit more in business, because you might do a business deal, you're compromising okay, you don't like how that partner is making you feel, but he's giving you some money, and that's okay. Like, that's your end goal. Now with the science, right, it gets a little, it's like the currency, the money are the ideas themselves, right? Because your reputation is all about the work you put out. And if you become a professor and you have tenure, you have job security for the rest of your life. So you're not worried about, I mean, there's still politics involved because you want to get money so you can get graduate students and all of that. But your ego of your own work is definitely more involved. So that it does make it a little, especially now because there's such, everyone's after trying to figure out what is this final theory of everything. And then it's basically everyone's trying to say who's going to be the next Einstein, right? And so that puts a lot of pressure on the entire community. And then it turns into this thing where a lot of scientists are so humble that they won't even go and try extremely ambitious things because it's like, how can I be better than Einstein? He was a genius, right? So the types of people that end up looking into the most advanced stuff, you end up getting a lot of these oddball characters, right? Because you kind of have to you have to kind of go against the grain to some degree to be ambitious enough to really dive into the most difficult problems. But at the same time, I should just say there's also just tons of scientists out there who are doing the right thing and are hard workers and are doing a great job and are making progress and are very helpful.
Well, I mean, you should have ambition in this kind of stuff, right? You got to sort of like inspire competition, I think. I think it's healthy to like create innovation. And I think that was one of the things that DARPA did. When I was reading that book, I was telling you about that DARPA book by Annie Jacobson. She was saying that they basically hired two different labs simultaneously. Instead of hiring only one lab specifically, they hired two, so they would have to compete against each other to make better shit.
Yeah.
And that was interesting because that's a great example of science being mixed with business for specifically for profit or for financial gain. In the military specifically. And, you know, I think a lot of, correct me if I'm wrong, but a lot of people that are in this field of study, whether it be physics or whatever, a lot of them just get complacent when they get tenure and they become professors and they just have like this job for life and they don't have to worry about a paycheck. They don't have to worry about money. They just kind of like show up and do what they have to do.
Yeah, I would say most professors are doing the right thing and are trying their best. They feel a sense of responsibility, but obviously they're humans at the end of the day, so there's a spectrum. And it depends on the university as well. I would say at the top universities, to get at that level, I mean, everyone's looking at you, so they're going to be top performing all the time, 100%. And it depends too. There's also, when you're a professor, there's teaching and then there's the research. And so some professors, they care only about the research, so they might neglect the teaching a little bit more. That's kind of a common trend. But yeah, and then, yeah, so there's, everyone's a little different. But I would say for the most part, it's not like a huge problem. I wouldn't try to advertise that there's too many professors being lazy, but I think it is a curious model in today's world where it is a little bizarre where you have this job where essentially it's a high risk opportunity to either become a professor or fail. Right? You either make it or you don't. And so it's this weird dichotomy of you either get a job for life or you're on the streets. It's a little strange because there are a lot of really smart people who just barely don't make that cut and then go in industry. And it is bizarre because a lot of people who stay in academia I feel, in my opinion, I feel like a lot of them are just trying to figure out what do I want to get as a job? And they're like, I don't know, but I'm good at school, so I'll just stay in school. And they get stuck there. So they're actually very conservative, but it's pretty risky to try to become a professor. Even when I was at MIT, I had an advisor that told me, do not try to become a professor because it's like trying to go to the NBA.
Really?
It's more or less that competitive. Maybe not that competitive, but it's definitely close to that in terms of getting a top job at a university.
Does a professor make good money?
Yeah, they make good money. I mean, it depends as well. It depends how you're getting grant money as well. But I mean, there's a base salary. Usually a lot of if it's a public university, the salaries might be public. You can make $150,000, $250,000 a year, maybe even a little more if you're like really at the top of your field.
Right. One of the things that Eric Weinstein was talking about recently was that like he was talking about this crazy stagnation that's been going on in physics for the last, what is it, like 34 years?
Right.
Since like the Hadron Collider, they started colliding particles, and then like nothing's really been done since.
I think that's a gross oversimplification of the situation. I would like to ask Eric Weinstein, I mean, how many papers has he read in the past 10 years? If he's saying there's been no progress, then clearly he must be reading papers to come to that decision. Otherwise, he's just saying that, right? There's so many scientific papers that are being put out. 100 years ago, there might have only been a few physicists in the US, maybe 150 years ago. There was literally only a couple physicists in the US that were top quality 150 years ago. And now there's how many? Hundreds, thousands. And the number of papers that are coming out is just exploding. It's happening way too fast. Nobody knows how to keep up with it. Now you can have a paper that gets 10,000 citations if you're top in your field. And so imagine if you publish a paper, it gets 10,000 citations. Now it's your job as a scientist to follow up. The first step of research is doing the research, looking into what people have done in the past and building on that. If you have to read 10,000 papers, that's just building off one idea. How are you going to keep track of all the progress that's happening? And so once you get overwhelmed by all this data, it's kind of like saying, oh, there's hundreds of thousands of papers coming out, you know, but all of them are useless. That's essentially what he's saying, right? I mean, I just don't believe that. I think there's a lot of progress that is occurring, even in the differential geometry, in the mathematics that he's talking about, that he says is useful for anti-gravity. Just in the past 5 years, the number of papers talking about the topics that he's like, what's happened to the stuff in the 1950s? Has he been reading what's on the internet? Because it's been exploding in the past decade. There's so much research.
Specifically talking about anti-gravity, like with Lewis Witten and Ed Witten, right?
Yeah. So at the end of the day, what that was all about, I mean, I haven't looked into it in great detail, but there were some people who wanted to fund anti-gravity, and they got top scientists to start looking into it. And so they started playing with all of this advanced differential geometry, this advanced mathematics that goes beyond Einstein's mathematics. But even Einstein himself, after he came out with general relativity in 1915, he still explored a lot of other ideas, including some of these exotic forms of differential geometry, such as torsion. And so people have looked into these, but Einstein is remembered for his 1915 theory, and then he tried unification, and everyone says that didn't work. So Einstein's failed unified field theory didn't pan out. But you know, the experts in that field were still looking at this geometry, and so that brings us up to the 1950s. General relativity came out in 1915 using the mathematics it had. Some additional mathematics was developed in the 1920s that's relevant for new theories of gravity. And the community is trying to figure out, the problem is there's too many good theories to explore. That's the real problem, is there's literally an infinite number of theories that limit to general relativity at the low energy, and we're trying to figure out which one is the right one. And so there's a lack of consensus on what is good. So everyone just goes back to general relativity because we know that works. And so Eric Weinstein is saying, hey, look, what happened in the 1950s, that everyone's just doing general relativity now. What about all this exotic mathematics, all this exotic space-time effects that you can have? Is that relevant? And literally, I looked at the number of papers for, it's not anti-gravity, not all the papers I'm talking about are specifically for applications to anti-gravity, but they're discussing the mathematics. Before you get to the technology, you have to get to the engineering, and before the engineering, you have to get to the science. And a lot of times the science and physics, the mathematics comes first. So we had the mathematics, and now we're in that process of doing the science, and it takes time.
How many papers are out there right now on this kind of stuff, on this anti-gravity?
Well, anti-gravity, I don't know, maybe dozens to hundreds, but
Have you looked at any of them?
I've looked at some. Yeah.
What's your process of like looking at one of these papers? Like, what do you have to do? Where do you go? What do you do? How long do they take to read?
Yeah, well, at this point in my career, I typically always try to skim papers. I tend to not read the words very much, and I try to just focus on the mathematics. So I'll look at the title, look at the abstract, and then just skim through the paper and try to see if there's equations that I've seen before.
Okay.
And then I try to see where they go from there. And so that's typically my process. I would say within the exotic differential geometry, like torsion and non-metricity, these weird terms, there's maybe 10 years ago, there'd be 10 papers a year, let's say, but it's kind of exploding. Now there's like 100, 200. I forget the exact numbers, but it's going up a curve. It's exploding right now.
Is this because of like the recent explosion in UFOs and aliens, like the interest in it? And
I'm not sure.
Do you think there's like an explosion of like new young people in college wanting to study physics and stuff like this?
I think everything is just expanding. I mean, our capability of making progress is expanding. So I think it's just everything all happening at once, and it's hard to figure out what's causing what, but they're all happening concurrently. So in my opinion, I don't think it's literally anti-gravity that's driving some of this progress. I think it's just due. It's ready to, like, the time is now to to explore these ideas. I mean, things have been somewhat stagnated to some degree, you could say, but it's also because we've run out of experiments to try too. So it's not the theory. Basically, we have too many theories to choose between and not enough experiments to confirm which is right. And someone like Eric Weinstein is blaming all the theorists, saying everyone got stuck. And it's like, no, everyone's not stuck. There's hundreds of ideas that we're exploring. And yeah, it's difficult to figure out how to experimentally test these different theories because what we already have is already so successful. And so it is a challenge, and there has been some slight stagnation, but as time goes on, people are just exploring more and more ideas. So the more exotic ideas over time just start to get explored more. And it's the type of thing where I've even found papers where a paper came out about 10 years ago. I noticed it didn't cite the original source of this theory that they were talking about. And I had that paper, and then I looked back, and it was from the 1960s. And then very recently, even a year ago, I'd looked at this paper about 3 years ago. About a year ago, I found a letter to Einstein in the 1920s showing how Einstein's unified theory was just a theory of gravity. And so what's happened is the mainstream physicists, even the experts in the community, haven't realized this. Only the pure gravity experts, a few of them, have figured this out, where Einstein had this attempted unified field theory. It turned out to not quite have electromagnetism, but was actually a good theory of gravity. And nobody seems to be paying attention to that. Well, until maybe 10 years ago, it's been starting to explore more. Well, it got explored in the 70s a bit, and then it kind of died down. And then another version of, so that used torsion. Einstein used torsion. So
what is torsion?
It's the torquing of space-time itself.
The torquing of space-time.
So general relativity has energy and momentum that sources gravitation, which is curvature. So like a sphere is curved, but it's not twisted, right?
Right.
So Élie Cartan, a mathematician, eventually he was studying physics theories as a mathematician and realized, wait a second, from the old mathematics from the 1800s, there should be something to twist space-time as well. He introduced this space-time torsion. And then this other guy, Weil, introduced non-metricity, which is even more exotic. That's even crazier than torsion. But it's like torsion is already so crazy that no one even hears about non-metricity because that's even more out there. And so these are the types of non-Riemannian geometry that Eric Weinstein was talking about. And you can see in his theory, he actually kind of is inspired by trying to make sense of some of those things, but I don't think he fully has studied all of the work that has come out in the past 30 years, which helps clarify much quickly how to get into exploring these topics.
Okay, this is an example of what torsion looks like?
Yeah, I mean, torsion is somewhat of a general term as well, so it gets used in other applications as well. So that's why I like to use the term space-time torsion, just to point out. But yeah, exactly.
Space-time torsion.
So you can imagine that rod or bar was space-time in some sense. And so The idea was that maybe spin should source torsion. That was the idea, right? Like if you have matter that's rotating, shouldn't it sort of drag or twist space-time with it in some way? That was Cartan's motivation. And he wasn't even interested in quantum mechanics. He was just interested in spin, angular momentum. You know, planets can spin. But it turns out that quantum theory, really a big part of it is about quantum spin. And so it turns out that that quantum spin is needed to source torsion. So the electron, it's just kind of a fact. If you want to go into how to look into studying the electron in curved spacetime and do it in the standard way, it requires torsion, but nobody likes to admit that in academia for the most part. And so no one is just trying to study quantizing that theory with torsion called Einstein-Cartan theory. I've done the research because I wanted to do this myself in graduate school. I realized that this should be computed to see if it's how it does for quantum gravity. It's the most reasonable thing to do. It's the most conservative thing to do. It makes mathematically, if you forget all of the stigma of human culture and you just look at the math, it's obvious that this is the thing to try, but my advisor didn't let me work on it. He thought it was too risky.
How would you try it?
It would involve calculations. So this would be trying to calculate the scattering of electrons with gravitons, the force carrier of gravity, and trying to see. So the problem with
Isn't gravity waves?
Gravitational waves, yes.
Okay.
Yep.
Okay.
Right. So gravitons are the particle aspect of gravitational waves.
Got
and
it.
so some people get tripped up on this and they say, oh, well, we know gravitational waves exist, but gravitons, we've never measured that. That's crazy, right?
Okay.
But if you think about light is an electromagnetic wave, but it's also a particle, the photon. Really, there's the photon field that has particle-like and wave-like aspects. And so
kind of both.
I'll admit that I'm coming at this from a quantum field theory perspective.
Okay.
And I'm saying that if you just think about what the photon is and you think about gravity, this is the interpretation. I mean, the gravitational field is, it contains gravitons and gravitational waves, just as the photon field can contain photons as particles and electromagnetic waves.
Okay.
So it's really not that ridiculous to imagine gravitons. And I actually, in my thesis, I computed how to use Feynman diagrams, which are these diagrams that get used in quantum field theory, but I used them to calculate general relativity results. And so this is kind of a thing that physicists are figuring out how to do better and better. They're actually figuring out how to use the mathematics developed for the Large Hadron Collider, which is colliding protons. And we kind of spent all our money. You know, we put it up as high energy as we can. We got all the tax dollars we could, and we found everything we could. We found exactly what we thought we would find. And now we're moving on to LIGO, which is this gravitational wave detector. Now we're, instead of
LIGO?
Yeah. That's the world's largest gravitational wave detector. They actually have 2 or 3 different locations around the globe, and they get signals from that outer space, and they correlate the signals across the entire Earth to identify. They triangulate the signal to figure out if because the experiments are so sensitive that if you have an earthquake nearby in one of these experiments, it sets off the detectors, or even just like a car driving by. So they have to set up.
Is this it?
Yeah, that's one of the detectors. So it's set up with that geometry to pick up on polarization, basically the spin of the graviton or the polarization of the gravitational waves is related to the design of this experiment itself. That's why it has that L shape. And so that's an interferometer. And so they're bouncing light around on mirrors, and the mirrors are sensitive down to 10 to the minus 18 meters, which is some of the most sensitive measurements in the world. So if those mirrors move by the tiniest fraction of a fraction of a fraction of an inch, it sets off a signal.
So this looks like 2 giant chopsticks crossing each other with mirrors inside them that are bouncing light beams
Exactly.
into the center.
So what happens is you have a laser, and the laser goes through a beam splitter. So you have the same type of light getting split, going down two directions, and it's bouncing off the end and coming back. And so the two lengths, the two arms are exactly the same length. And so it's trying to measure, do the photons come back at exactly the same time? Or is there a gravitational wave that came through and messed it up? So if they're coming in, they're going out into the two arms at the same time and coming back. If there's no gravitational waves, they're going to come back, reflect off the end,
4
and come back
kilometer
at
length.
the same exact time. And so the detector is, so you see how the detector is kind of flanking the laser, right? Because after it bounces off the test mass at the end of the arm, it comes back and it gets merged together and goes into the detector to see if the two photons came back at the same time or if there was a slight time delay. If there's a time delay, then they're implying that there must have been some space-time curvature that caused length to get deformed, so it actually had to travel a larger distance on one of the arms than the other.
So what are they finding with their tests?
They've already found, to their surprise, they found signals way before they were expecting. Part of the reason was because
They found signals before they were expecting.
Yeah, because we can't control when signals come in. Like the LHC, we control the protons. Those are what's colliding. LIGO is using stars in the universe as their protons. So they're waiting for some random event in the sky to happen where two black holes just collide. And it's one of the most energetic processes in the entire universe. It's so chaotic. The explosion that went off that they detected, it's so crazy how big of an explosion was. If you were a solar system nearby, you would have been obliterated, absolutely obliterated. So we got lucky. There happened to be this huge explosion of two black holes colliding. And now they've measured other stars as well. There's neutron stars.
How do they detect this?
So the idea is
how far away are these black holes that are exploding into each other? Sorry to interrupt, but this episode of the podcast is brought to you by Verso. We all know how important it is to get the right amount of nutrition, exercise, and sleep as we age. It's something I'm really passionate about and have discussed at length with doctors and nutritional scientists on this podcast. That is why I use Verso. Verso is a company dedicated into translating scientific breakthroughs into products that hold the potential to increase longevity. I take Cell Being every day to help combat aging by increasing my NAD levels with powerful ingredients such as NMN, trans-resveratrol, and TMG. NAD Plus is arguably one of the most powerful molecules in the body, but declines with age. Keeping NAD Plus levels high helps guide longevity genes called sirtuins. Sirtuins are called longevity genes because by activating them, they support overall health and slow down aging-related effects by regulating important processes inside of cells. High NAD Plus levels can improve your metabolism, repair damaged DNA, and ramp up energy production in your brain, immune system, and muscles. Now, you can't take NAD Plus as a supplement because it's too big for the cells to absorb. But NMN directly converts to NAD+, while resveratrol activates your sirtuins, which increases their attraction for NAD. These two molecules act synergistically and increase your NAD+ more than just NMN on its own. Verso also publishes third-party testing from each batch produced to absolutely guarantee you're getting what you pay for. Head on over to ver.so and use the coupon code CONCRETE at checkout to save 15% off your entire order. Or go to ver.so/KONCRETE right now. It's linked below. Now back to the show.
Right. So they're very far away. In other there are other solar systems, other galaxies, and basically the idea is that by the time the gravitational waves get to us, it's very weak. It's very faint, and that's why it's so hard to detect because they're so far away. You have it exactly right. So the basic idea is there's a trade-off, right? Do we make gravitational waves in a lab, and then gravitational waves are kind of like light. If you turn on a light bulb, the further away you get from the light source, the less light you see because light's going everywhere, right?
Yes.
So it doesn't make sense to put a light bulb in the other room and light your room. Same thing here. So you could say, right, it might be a smart thing to say, well, can I make it in a laboratory and just create the gravitational waves and then detect them immediately? It actually turns out some people tried that, but there was some controversy. It wasn't clear if it was detected or not, I believe in the 1970s perhaps. And so now people have realized that, well, if we get lucky enough for the right explosion to happen out in the universe, then we can actually detect the gravitational waves. So the gravitational waves near the source where the collision happens, they're very chaotic, very difficult to predict. It's a high energy process, and it's very complicated. And so, but by the time the gravitational waves get to us, it's so faint, it actually makes it easier to try to understand, because you can use the low energy theory, because by the time the gravitational waves get to us, it's not too chaotic.
Right.
So we have a better handle on how to detect that. It's much more established. There's a very solid consensus on how we should detect that.
Haven't they been trying to make, or haven't they successfully made a black hole in a laboratory? I heard that was...
I'm not aware of that. There was speculation that maybe proton collisions could lead to the creation of a black hole, but that was a little bit of a speculative idea that gets caught in the press and gets hyped up a little bit.
Can you try to find that, Steven? Black hole made in a lab? I swear I saw that somewhere.
I remember hearing about it, and physicists saying that it disappears after like 0.00 seconds.
Oh, it disappears real quick?
Yeah, I mean, there could have been some experiment too, but that one. Okay, that
Researchers
one.
at the University of Amsterdam were able to create a simulated black hole in a lab. In a paper published by the Journal of Physical Review Research, the scientists claimed that they were able to create a chain of atoms. Electrons skipped along the chain, creating a sort of wave.
So if I remember correctly, that might have been this experiment where did they also do something in a quantum computer? Was that the same one I'm thinking of? I know there was some experiment where, it was like an analogy. So that there's different analogies in these different theories. So I know maybe this is different than the one I'm thinking of, but I know there was one experiment where they kind of simulated a black hole in a quantum computer in a way. And so people thought it was support for the idea that the mathematics of quantum gravity makes sense. But it's a little, there's like this analogy that's happening there. So it depends on assuming that analogy is right. But yeah, I'd have to look more into the details for this one.
Scientists create a black...
Okay. In the Netherlands. Yeah, that's the one I saw. Create a lab-grown black hole in the Netherlands.
Okay. Maybe
down.
that one's a little different then. That's interesting.
Zoom in on that highlighted part. Using a single file chain of atoms to simulate an event horizon, Mertens allowed electrons to skip from one position to the next. This caused certain properties of the element to vanish, creating an event horizon that changed the wave-like nature of the surrounding electrons. What does that mean?
Well, it's hard to tell, right? Because they're saying it simulated an event horizon, which to me means, was it a real event horizon? It's hard to tell. What does that even mean? And also, there's a theory that all of the fundamental particles could be black holes. We don't even know.
Wait, what?
Some people have, Frank Wilczek who's a Nobel laureate, have said that elementary particles such as an electron could be an extremal black hole, a black hole that's kind of at its limit. And so that's an idea that we're not sure yet. That has been studied in string theory a lot as well, but we're still trying to figure out how to connect string theory to the real world. So in some sense, it might turn out that once we have a unified field theory, the notion of creating a black hole could be a trivial thing, because a black hole is just a massive particle, really. It's a point source of mass at the end of the day. It creates an event horizon. I mean, even the sun, if you're really far away from the sun, mathematically, the first approximation is just to pretend the sun is a black hole, because it's a point object.
Right.
When you're really far away and you don't care about the size of the sun, you might as well just pretend it's a black hole. If you're far enough away.
Okay.
It's just a mathematical approximation that does the trick really well. So when you think about what are particles, right? What's the difference between the sun, when you zoom out and the sun just turns into a dot?
Right.
How is that different than an electron? We don't know yet. We're still trying to figure out how an electron should work in quantum gravity. And so one possible solution is to say, well, maybe electrons are actually black holes, but stable black holes.
Right.
So, but now what's more established, what's hot in the community is to say, well, we know that black holes can radiate Hawking radiation. There's more and more evidence suggesting that this is possible. So it suggests that black holes are in some sense, especially when they're really large, they're unstable. They slowly radiate energy away and eventually become smaller. So we don't understand exactly, there's different theories. There's, a lot of work actually exploring this, and I haven't even looked into all of the literature because, as I was mentioning, there's so many papers, but some people are saying eventually everything will just Hawking radiate away and the whole black hole would disappear. Other people are saying, well, no, eventually it's going to reach this limit where it can't radiate anymore and it could become a stable particle. So that's something that's still, I would say, up for debate.
Going back to string theory, what basically is the debate between scientists with string theory? Like, what's going on with string theory? Why did Weinstein call Michio Kaku crazy and out of his mind?
Well, okay, so I would say that there has been some political issues. I would say string theorists are very bad at PR. They're scientists, not marketers. And also just the way that the culture works, academics got comfortable with getting support from the government after World War II. And so they got comfortable to not explaining their ideas to the public because they were getting funding, because they were saying, hey, look, if we research this, we got to stop Russia. We got to stay on top of Russia. That whole mentality in academia is dying off. So now when you get into
this,
well, to some degree, I mean, it's not the Cold War anymore. I mean, yeah,
right.
Okay, things have been heightened to some degree, but I don't know. To me, I wasn't alive then, but I feel like the tension after World War II is a little heightened, I would say.
Right. Oh yeah, for sure.
And so now we're at this point where people are asking for money in the same ways that they used to in the 70s, and it's getting a little bit harder. And they lost their skills at communicating. I mean, scientists aren't always the best communicators. But okay, let's dive into the details a little more. So string theory at first was in the 70s was just an attempt to describe the strong force, which relates to the proton-proton collisions. You get a lot of the forces involved there are the strong force.
Okay.
And so they were trying to figure out what happened there, and they realized that the math kind of got simpler when you look at high energy processes. And notice that key, the math got simpler.
At high energy.
Yeah, and that's true in general. And so what they realized is when you look at this high energy physics, it actually looks like the force carrier of the strong force might actually be a string, an extended object, rather than a particle.
Okay.
And so that was the idea, and they ran with it, but they started studying this theory more, and then they realized it was a theory of quantum gravity. So that got exciting. But then it kind of hit some other roadblocks. Eventually they started to realize that it seemed to solve problems that other theories ran into. But there's a debate over that. It's some people, it's a very small community, a very small minority thinks that result maybe not be as important. Mm-hmm. But anyways, basically what happens is the string theorists find successful things that make the theory look like it might be a good theory, but there's no concrete experimental evidence. And so one of these things that was predicted was extra particles. And so, but part of the problem is they haven't explored all the ways to use the math. And so they developed one theory, the minimally supersymmetric standard model, okay, and that predicted some extra particles. They didn't know the mass of the particle, and they wanted grant money. So they said, hey, maybe the LHC can detect these particles. But there was actually no reason to ever suspect that the LHC could detect those particles. They had no idea what them, and it seemed like the mass of these particles had to be really high. Mm-hmm. And Einstein said E equals mc squared, so high mass means high energy.
Right.
And so as I was mentioning, this high energy theory, that's where things, that's the unknown. We don't know what's going on there. Right? And so we know the string theorists were saying they think that these particles should exist, but they have no idea what energy. I mean, it could be way higher, but they said, hey, maybe it's really low energy, even though there was kind of arguments suggesting it shouldn't be found at low energies. And they ran with it anyways. And the entire community didn't, like a lot of the experts in the field latched onto it and believed the story to get the grant money, and it didn't work. The LHC never detected anything else. But there was never actually any good reason to expect it in the first place. So then a lot of people say, oh, that proves string theory is wrong because, it's... And so they could always say, well, these particles come in at higher and higher energy, so people claim it's unfalsifiable. And a lot of string theorists also aren't sure if it's falsifiable or not. I think it actually is falsifiable for other reasons, but and I want to stress that I don't see myself as a string theorist either. I didn't want to study string theory in grad school because I didn't like the state of the community. So I'm not saying this as someone from the inside, so to speak. I looked at myself as an outsider to the string theory community. I cared more about quantum field theory. My whole thing was gravity can be treated as a quantum field theory. And the string theorists are basically saying, no, quantum field theory doesn't work for gravity. But it turns out even to get good string theory, which is some of the work that Michio Kaku did, was for string field theory, which is quantum field theory of strings. So from my perspective, string theory is kind of ripping off quantum field theory, because at the end of the day, string theory is just another quantum field theory. And so they're trying to portray it as this different final theory, when really we know quantum field theory works well for the LHC, all the particle collisions. And so there's kind of this dilemma, right? This marketing campaign issue where people are labeling, to me, it's all the same stuff, but some theories have supersymmetry, some theories don't. And then the ones with supersymmetry often get looped into string theory, which is just some weird symmetry. It's just some weird mathematics that they like that gets around some no-go theorem. And so Eric Weinstein is basically saying, can't we just ignore all the no-go theorems and play around with ideas? And I mean, in some regards, that's a little disrespectful to previous work, right? If someone puts out a paper and says this whole direction doesn't work for some reasons, I mean, typically if you want to publish something else, you have to describe, if you come up with a new answer, that's fine as long as you can describe why that no-go doesn't apply to your work. But Eric Weinstein is saying, let's just ignore all these no-go theorems. Let's just carry on anyways and just disregard what other scientists are saying.
What is a no-go again?
Okay, yeah. So this happens a lot where they'll come up with some like math theorem that says you can't do this. It's a no-go.
Okay.
And so it's a little problematic because a lot of times there's kind of baked in assumptions that don't get articulated. Really what usually happens is the paper is written really well and the assumptions are stated very clearly. And so they'll say, assuming A, B, and C, D isn't possible. But then culturally, people read the papers and they start to forget about the assumptions and they start to get a little dogmatic with it. I've seen this happen in string theory where I have some work that got around some of the no-go theorems, and it's difficult for me to share my work with the string theorists because they won't even look at it because there's this no-go theorem that I heard about that I haven't even looked into because there's so many papers. So I don't know how to, I feel uncomfortable, so I'm not even going to touch it, right? So that's pretty common, where really everyone's overloaded with work and trying to identify what's something concrete that they can actually understand and make progress with. And so that's why I don't get too mad at people for suppressing. It's not suppression. It's just that everyone has a finite attention span and is trying to focus on what they can grasp. And so if you haven't studied this no-go theorem in detail, and someone is presenting a new idea that claims to get around the no-go theorem, but is different, you have to evaluate, well, did they actually get around that no-go theorem, yes or no, which means you have to read that paper. And sometimes they can get pretty technical, and some people don't want to spend their time doing those things. So they'd prefer studying something that they understand better. I mean, one time my advisor told me, why do poets write poetry? I was trying to say, well, if we're high energy theorists, and there's this energy crisis, shouldn't we eventually try to figure out how to use high energy theory to solve energy crises that humanity is facing? And I got a resounding no, that's not the idea, right? And I was doing a little bit of play of words there because high energy theory isn't high energy in the same sense of what humans might mean, but still, like at the end of the day, people have the freedom to choose to look into whatever they want, and we have to respect that freedom. And to me, it's all about maximizing our potential for freedom. And
that's what Eric's talking about.
Well, yeah, I mean,
he's basically saying there needs to be more of this quote unquote blue sky research.
He wants more adventurous research, which I mean, I think you could make the case for it. It could be helpful, but I mean, there's also people that do that. I mean, So it's a balance, and yeah, so it's all about where's that balance. So, how many people do you have chase after the conventional ideas, and how many people you have chasing the unconventional?
Which is what you guys are sort of doing at your lab, right? You guys are chasing the unconventional stuff.
Yeah, I would say that we are willing to look into arcane topics, and we're thinking about consciousness. I mean, some physicists don't even think about consciousness at all and think it's almost, you shouldn't even do that. You shouldn't even bring consciousness into physics because we kind of need to figure out physics first. Or maybe from a materialist point of view, it's all just physics anyways. Maybe consciousness isn't a thing and it's just emergent from matter. But we do take, at quantum gravity research, we do take a more panpsychist view where we try to think of consciousness as the substrate of reality where matter emerges out of. So it's just a different perspective to take. But yeah, so we're open-minded towards things like that.
So what do you think consciousness is?
Well, the problem is you can come up with different definitions, and that's the real problem. What most people think of as consciousness isn't very precise. It's a vague collection of all these things. Mm-hmm. Even a word in a dictionary, right? It's all defined in a circular way because you define a word in terms of other words, which are defined in terms of those words. Yeah. And so it turns into a semantic nightmare. Uh-huh. Sometimes I just think of consciousness as abstract information, but the more conventional definition relates to this notion of experience or qualia, or having this notion of like feeling like you're, feeling an experience rather than just raw data being processed. But right. I think of consciousness personally, I think of it as data that you take in from the external world and you modify that data in a way that isn't based on external data. So it's like light comes into your eyes and it might be photons at a certain frequency, but then we have this experience of redness, right? And that's often associated with qualia. People might have an emotional response to color. Those emotional responses aren't based on the external world. Those are based on our internal memories.
Right.
So I think of it as data conversion. Okay. So it's like you're converting from one basis to another. And when the basis you're converting to is constructed from your own internal like neural network that you've created, to me, that might be consciousness, because you're using your freedom to decide how to interpret the data, which is a unique experience, in my opinion. That's just how I look at it.
Right. And who is the guy who started this research company that you're working for? Yeah,
Klee Irwin started this nonprofit as a philanthropic.
What's his first name?
Klee Irwin.
Klee Irwin.
Klee.
Right.
Irwin with an I. And so, yeah, he basically was this entrepreneur who was a materialist. And then he had this son who had psychic abilities and could remote view. And that blew his worldview. It just shocked him. He didn't know how to think about it. It made him think deeply, well, what is reality?
How do you discover that your son has psychic abilities?
I don't know exactly how he first noticed it, but I've just heard some of the stories of some of the things he did where he would start testing his son. Like he would take a banana and then like hide it somewhere in his house and then ask his son, be like, where is the banana? And his son would just tell him. And there was a few other little things that he would try.
He told you this?
That's what he told me.
Wow.
Yeah. I mean.
Oh, is this him?
Yeah, exactly. So he, based on his own son's experiences, he started believing in remote viewing. And then he started thinking about, well, how does that even possible if I'm a materialist? And so he eventually started asking more questions. Well, like, what are the experts saying? What are the scientists saying? And he started to realize we don't understand as much as maybe he thought we understand. We have theories that can give you solutions, but they don't always explain why. Why is always a very difficult question to answer. You can answer what, or, I mean, why, you can say what might happen next, but why it happened is a little deeper. And so I think that question of why kind of motivated him to start this institute where he decided, well, he was a successful businessman, so he decided that he wanted to help and give back to humanity, and that's how he thought he could help the most. At first, he thought of looking into solar cells. He wanted to help the world with the energy crisis and issue there, and then he looked into it and he realized, well, there's actually a big impact when you're making all the chips that go into the solar panels. So he stopped that business venture because he realized it wasn't helping the world as much as he thought.
Manufacturing the chips?
Yeah, there's silicon that goes in the solar panels. So, I mean, once the solar panel is built, they're very efficient, and they're low impact on the environment. But to create those solar panels in the first place, I mean, if you make a few of them, it's fine. But if you're trying to make it for the entire planet, eventually you're running into resources that need to create those solar panels.
Right.
And that has an impact as well on the environment. So, yeah, he was just self-motivated to try to figure out how the world works, really.
And he's basically just dumping all this money into this with no expectation for any sort of return on any investment. He's just fascinated by this.
Yeah, for him, his return on investment is developing this theory. So it's not exactly like we have full freedom to explore whatever we want. He's very mission critical. He's not also, he's also in the research process. He's one of the scientists now. He's been co-authors on all the papers that we've been doing. And so he's helping out guide that process. He sees it as almost like a Manhattan Project where mission critical, we're trying to figure out what this theory of consciousness and information and energy and how it all fits together. Most people aren't even attempting it because it's too taboo.
What does he think it can solve?
I mean, everything to some degree.
Everything.
Well, I mean, you could ask, well, how far will we eventually get? I mean, maybe we'll just find some approximation that gets us closer to the truth. That's a possibility, right? I mean, trying to describe how the world works always leads to unexpected consequences. It's very hard to predict. Sometimes you can predict some of the things that might occur. I mean, electricity, maybe. I mean, Nikola Tesla was a great example of someone who could see where the technology would go, because he invented alternating current, and then he even had designs for crafts. He saw this vision of transferring files through the air, like Wi-Fi, but he wanted to do it differently, a little bit differently, but he had that vision to see where the technology would come from the science. But sometimes it's hard to predict what will come out. You develop the theory, and then a few decades go by, and we get surprised all the time.
We talked about this a little bit yesterday, but we were talking about free energy. Can you explain what free energy is?
Well, okay, so yeah, speaking of Tesla, he had this dream of somehow providing free energy to everyone.
Yeah.
Essentially, he was contracted to build some energy grid, and he decided to do a side deal where rather than building what he was asked with the money he was given, he wanted to give free energy to everyone. And unsurprisingly, the investors weren't very happy with that, right? They didn't get their return on investment, so Tesla didn't finish that dream. And no one really understood the science for how that could be possible anyway. So it's sort of a fringe thing, where a lot of people are obsessed with Tesla and trying to read his patents and figure out and piece it together and try to figure out, can you make a free energy machine or a perpetual mobile or something that you just push a button and it just gives you free energy automatically. And so I started looking into some of these things just because I was originally not interested in free energy. I was just interested in efficient uses of energy, which is fine. We're always making more efficient engines. And I was curious to see if quantum field theory would eventually help create new engines. That's what I started looking into. So I thought about it as physics leads to engineering, leads to technology. And it's hard to see how quantum field theory could lead to technology right now. It's very difficult for us to see it because it's so technical, it's so advanced. But I kind of made a bet that it will one day lead there, just as quantum mechanics did. Before we had computers, before we had transistors, people were studying this new mathematics that seemed weird. And I'm sure it was probably difficult to see how quantum mechanics might be, maybe, okay, you have electrons, we already had electricity, so there's some intuition that quantum mechanics will help. But it helped technology a lot. So I just figured, well, can quantum field theory help technology? And when I started looking into how that might work, a lot of it was grounded on thinking about this quantum vacuum, which, as I was mentioning, is something that it's very subtle. It gets excited by all particles. So it has access to the potential of all particles, but they're not actualized in some sense. So there's this notion of physical particles and then virtual particles, and the virtual particles are sort of in the quantum vacuum. And Paul Dirac, who came up with the theory for the electron, who's a titan in physics, said that the ether is this quantum vacuum.
The ether.
The ether, which originally was, this goes back to Greek philosophy, it's this medium. But around the 1800s, people thought there was this electromagnetic ether, this luminiferous ether that was the medium for electromagnetic waves. But when quantum mechanics came out, well, special relativity kind of banished that ether and created a new mechanics. Mm-hmm. Basically, what happened over time is space-time essentially replaced the ether, because Maxwell's equations for electrodynamics ended up inspiring Einstein to create this new paradigm of mechanics in special relativity, which then led to general relativity as a theory of gravity. And so that wasn't a quantum theory. So Einstein had no ether in his way of thinking, but then quantum field theory was building off of quantum mechanics and seems to have this subtle vacuum, this subtle medium. And there's still debate on whether this medium is real or not. And also that's a problem, because what does it mean to be real? It's a semantical term.
Yes.
So you can imagine there's tons of philosophical debates and confusion on the physical nature of the quantum vacuum. And so I was just trying to study this quantum vacuum and try to understand its properties from a conventional sense in quantum field theory. I kept looking into it, and I started finding all this free energy stuff. The only stuff I could find were these amateurs talking about free energy, and I started just looking into it. I felt like as a scientist, it was my job to not reject information. I mean, you have to do your best to choose the information, but you never know where you're going to get good ideas. So I tried to be very open-minded and just collect information and not just blindly believe it, but just keep it in my back pocket in case it comes back later, start collecting. And I kept running into all these things like geopolitics or anti-gravity. I didn't care about any of that. And I just kept looking into trying to understand what this quantum vacuum was from the way I was looking at it. And I always found these people talking about the same topics, and all of them sound crazy. It's like, oh, free energy, aliens, UFOs. And it was hard to know what to think of it, but eventually I started to piece together why this is happening. It's because the physics for free energy could be related to the physics of UFOs if you believe that UFOs can be made, right? And now that's a lot different. People have a different mentality of it in the past decade than maybe 10, 20 years ago. It was kind of laughed at. Now you have physicists going on record saying, okay, maybe there's something here. No one seems to be seriously looking into it, but people are at the public level acknowledging that, okay, maybe there's something going on.
Yeah, it was funny that Weinstein said that he said that like when it comes to those videos, like those Tic Tac and the Go Fast videos of those UFOs that those Navy pilots recorded, he said that even people like Ed Witten aren't even in striking distance of being able to explain technology like this.
Well, there's a lot of bizarre things I don't understand where people are saying, he
also said he thought those videos were a smokescreen.
Yeah, so we don't know the origin of all these craft, but a lot of people will put out these claims that it violates laws of physics. It violates laws. What laws of physics are these UFOs violating? I don't understand this concept. I don't understand why Michio Kaku might say something like that. Okay, so it's going faster than the speed of sound, but it's not going faster than the speed of light. There's no problem there. The real issue is Ed Witten isn't an engineer. Why would Ed Witten know? It's like, would you go to Ed Witten to figure out how a Tesla works, the car? You know what I mean? Right. Like a UFO is more complicated than a car. So why would a theoretical physicist who's an expert in mathematics have answers for how the engineering of a UFO? It's just a weird question for me.
Maybe he was speaking specifically about anti-gravity.
Yeah,
assuming that that's how those things are moving is with anti-gravity.
Yeah, but we don't even know. All we know is it's moving.
Right.
I mean, okay, so then people say, what's the propulsion source, right? Okay. But still, we don't, at the end of the day, we don't know exactly what it's doing. But that doesn't mean that we don't know the physics behind it. We just don't know what it is. We don't know if it's old physics or new physics. So people are speculating that it must be new physics, and maybe it is. Maybe there is some stuff that's happening that could be related to new physics, but maybe it's just using electromagnetism in creative ways that we don't understand yet. I don't know.
Well, it's defying. It may not be defying physics, but it's defying like modern propulsion, right? It doesn't
right,
propel
exactly.
Like
so this idea that humans can't make it yet in 2023, so it must be violating laws of physics. Well, to me, there's a large gap there.
Right. Yeah. Absolutely. What is your opinion on those things? What do you think they could be? Are you even interested in that at all, or?
I mean, mildly, I guess. I just kind of keep an eye on it. I don't look into it too obsessively, but I don't know what to think exactly. I think it's possible that the private sector has more advanced technology than most, even maybe in academia, realize. I think it's a little curious that a lot of these sightings of specific types of craft seem to happen around military bases. So I don't know if that's implying that it's coming from military or if these extraterrestrials are interested in military bases. It could be both. I don't really know, but I think to me, it seems reasonable to think that some of these things in the sky could actually be man-made, but maybe there's other stuff in the sky that isn't man-made too. I don't think that there's necessarily one answer for everything. Obviously, a lot of these sightings in the public are fake. You know, like people will see things in the sky all the time and say, oh, that must be a UFO.
Right.
A lot of those are probably fake, but maybe some of them are something.
Do you think it's possible that they are from another dimension?
I mean, it's possible, but yeah, it's possible, but it's hard to, I would say in terms of.
What does your guy think?
Okay,
Irwin.
yeah. So Klee Irwin has an interesting idea where he thinks they're actually our descendants coming back from the future to kind of, they're not interacting directly to try to just give us little hints to try to get our crap together. You know, we need to evolve. We need to get more serious, think more than ourselves. We as humans, we think we're the king of the jungle of planet Earth. We're at the top of the food chain. But what if there's something bigger, right? We need to kind of grow up a little bit to get ready to potentially be a part of a bigger community.
Right.
And if that occurs, we might need to mature a little bit.
I think it's interesting. The whole phenomena is so interesting because I'm super interested in how similar it is to religion, because this phenomena it finds a way to stay on the fine line. It dances a fine line between giving just enough proof for people who are willing to believe and want to believe it, but not enough for people who require actual evidence to believe it. And in that aspect, it's kind of religious.
It is strange. To me, that's also bizarre too, which makes me wonder, maybe, I don't know, something intentional seems to be done by someone, right? They're not it's like just landing on planet Earth.
Exactly.
They're purposely making it, right? So what's going on there? I don't know if there's some other agenda to try to change the perception of humanity as well. We don't know what's happening exactly. You know, maybe what if it turns out that there are UFOs that are from outer space, but they're staying at a higher level or not interacting with us? And what if the military sees that and wants to control our perception? And so they're putting in these deep fakes. I don't know. It's a possibility. Anything's possible, really. I mean, that's a lesson from quantum mechanics. Anything that can happen will happen, but obviously we can't take that too literally. But, you know, we should be open-minded. We shouldn't, it's very easy to just try to think of a list of what it could be and come up with a very small list, but it's hard to know.
When you see all this stuff coming out, like in the news and like the mainstream media, and this guy, this Grusch whistleblower, and, you know, going on whatever he went on, 60 Minutes or something, to talk about how there's UFO crafts with aliens. You I wonder how much of that is like a smokescreen or a limited hangout, and how much of it is real. Like if they're going to give us that,
Yeah, it's strange.
what is really going on?
Yeah, it's hard to know. I mean, I didn't even pay attention too much to the Grusch stuff, but I think I saw one analysis, and that showed some of his clips. And the interview, I mean, maybe I didn't see the whole interview, but it just seems strange. He seemed like a little excited, and would be very non-specific with his answers. So it's very hard to debunk what he's saying. He was just saying very vague statements. And so it was a little strange to know what's the point of that? What's the make of all that, right? I mean, I think at the end of the day, it's clear that the some people maybe in the military or government, there are a lot of people that just want the best, and they're worried that society will freak out too much and will cause chaos. And so that's another angle too. There could just be a lot of good people who just want to protect ourselves from what's going on, because it might be too, people could have like schizophrenic breaks from realizing, right, religion, if there are UFOs and extraterrestrials, what does that do to religions? It could break people's psyche to some degree. So depending on how you look at it, some people are hungry for all the information to be released. And some people, I think people tend to think that if information is hidden, that it must be nefarious. But sometimes people hide information because they want to protect as well. And maybe there's both of those things going on. Maybe there's some people that want to hide information for positive means, and maybe others have their own agendas. Who knows?
Yeah. Yeah, I don't know. I honestly think that if that did come out and like they admitted and showed, like they paraded a fucking flying saucer down whatever Pennsylvania Avenue to show everybody, I think it would stay in the headlines for a couple days, and I think people would forget about it. I don't think people would care. Yeah,
and I think that the
like
public
we think about it like it would be a bigger thing than it really would be. I think people are just too distracted with everyday life to give a fuck.
Yeah. Yeah.
I mean, there'd be some really good podcasts and documentaries that come out, and like people like talking about it, and it would be entertaining, I think.
Right? Isn't the mystery almost more entertaining?
Yeah, the mystery is more. I mean, yeah, it's definitely more entertaining than if it actually came out and we all knew about it. Then I wonder what would be the next mystery. There have to be something to replace it.
Right. So we'll see. We'll see what happens.
The beings would be the next thing.
Yeah, right.
Have you heard about the stories of like those things coming out, like the beings coming out and talking to children?
I mean, I've heard a lot of stories. I mean, I've heard of...
There's tons of stories of these things like hovering around schools and landing at schools and like communicating with the children telepathically, saying that like technology is bad for humanity.
There was something in World War I that I forget it happened. Maybe was it Argentina? I don't know. There was some event where I think the first sighting, there wasn't very many people. And then the second sighting, there was maybe almost 20,000 children that got involved. And then there was going to be a third sighting. And then the government came in and shut the whole thing down.
Really?
That was 100 years ago.
What do you think about Bob Lazar?
I would say overall, it's a little, he seems like more of an attention seeker than he puts off on Joe Rogan. I mean, if you just look at his background, he's obviously a smart, intelligent guy. And he would do funny things like he would get a glorified jet engine and put it on a bicycle that his friend made and ride it around Los Alamos. I mean, I'm just saying that's a pretty eccentric thing to do.
Right.
To ride around on a bicycle with a jet engine. It's a little, I mean, he would throw parties in the desert where he just, a lot of people get obsessed with explosions. And so he would bring people out in the desert and would blow off all these explosions for entertainment. He ran a brothel at some point.
Right.
Okay. I mean, and then for me personally, the thing that really convinced me was the claims of his education. I just don't, I mean, obviously I'm biased.
What are the claims of his education?
I'm biased.
People who don't know, what is it that he says he did?
He claims that he got a degree from MIT, but there's no record of that degree. And so he's claiming that, I don't know, the government or whoever wiped all of the records of this. And so he's claiming that there's this secret backdoor of getting people education to study this stuff. And there is some reason to believe that it might be true because he did work for Los Alamos, it seems. and Los Alamos denied that. So Los Alamos is this research center in the desert, and it seems like Bob Lazar worked there, I don't know, maybe for a few months, and then got fired.
And Los Alamos denied
And they
it?
denied him ever working there. And so that's, once people found some document, someone found a document with Bob Lazar's name on it, implying that it was some record that he was an employee. And so that was the evidence saying, oh, see, there is a lie here. And then, so there's this bigger thing. I mean, at the end of the day, I don't know. I've never met Bob Lazar. I've never talked to him, but I did see a claim where someone said they asked him, okay, so if you went to MIT, what professors did you have? Which is a good question, right? And he ended up naming, I heard that he ended up naming some people that weren't professors at MIT, and one of them was a professor at some local community college in California. I mean, if that's true, to me, that shows that he's lying. And also, it is a little strange to me to expect that backdoor thing to be, I don't know, it just seems like a bizarre thing. So also, what did he do as a career? I mean, he has this company that sells exotic materials for tinkers. If you wanted to build a UFO and get exotic materials, you might buy something from his company. So wouldn't it help to become an urban legend in the UFO community to, I mean, I don't know. I haven't looked into the dates and this and that. So maybe he did premeditate that, maybe not. I don't know when he started his company exactly and when he started making claims. But also there's just other things, like he seems to get a lot of information from John Lear. And
yeah, what's the story with John Lear?
I mean, and once again, I don't know the full details. I don't dive into it as much as someone like Jeremy Rys does, but I mean,
Jeremy goes super deep.
Yeah, I mean, he's all into the UFOs. I mean, I'm not solely a UFO anti-gravity guy. I just happen to be interested in theoretical physics, and then, anything that sounds interesting, I'm interested in, I suppose. So, I mean, he also talked about very similar things as Bob Lazar right before, and I don't know where he worked or what connections John Lear had, but it's possible that Bob Lazar got some accurate information from him and then spiced it up. I don't know. I don't know what it is.
Is it possible that MIT would hide his record of going there for if he was part of some top secret government program, they needed him to go there to learn something for some sort of nefarious thing that DARPA was working on or something?
I mean, I can't say it's not possible.
Isn't there secret programs at MIT?
I mean, there's secrets, I suppose, but I've never heard of anything like that, but that doesn't mean anything either.
Yeah.
It's just it is a bold claim to say. And to me, it's really just the fact that he didn't name any professors, right? If you went there, it's such a strange thing, right? How can you hide, so you're going to go to classes with other students who are there. Wouldn't there be someone in that class that met him? Right. How do you hide that? How is it even possible to give a secret degree? Is he going to these classes or not? I don't know. So it's a little strange. I don't know. Yeah.
And there was also apparently, according to Jeremy, there was some college where they was doing basically you could pay to get your degree there. You could it was I forget the term he used. A degree mill. That's what he said it was, and he said that they got busted and they got shut down.
Yeah, and did he get a degree from there?
Something Pacific College,
right,
yeah.
Right, so there was some legal case where Bob Lazar didn't say he went to MIT. So under oath, he changes his story or something like this, right? Because he ran a brothel and there was some incident. I don't know, there was some lawsuit. I wouldn't be surprised if what happened is he wanted to work at Los Alamos and he was trying to find a way in, and maybe he convinced someone at Los Alamos, hey, I can help you reverse engineer whatever, and someone there bought it, but they didn't want to tell their supervisor, right? And they're like, let's give this kid a chance. And then once they let him in, they're like, wait a second, this guy is kind of a hot cannon. He's running a brothel, doing explosions in the desert. We got to cover this up. To me, that seems like the most likely thing. It makes a lot of sense to me. I don't know. Right. It just seems more likely than adding on more layers of craziness. And who knows? I mean, maybe he did work there and did see something in a window for 3 seconds. I have no idea. I mean, maybe there's some partial truth in a story, but to me, it seems like there's a couple cracks.
What do you think about how he was describing that reactor that was at the center of that flying saucer? He said there was like a basketball-sized reactor that if you put your hands close to it, it pushed your hands away from it. And he explained that remember how he explained it, that thing sort of like bent gravity around it and helped those things like basically fall through the air. Yeah.
I mean, it's hard to know what to make of that. I mean, is it have
and
to
then
be,
element 115?
That's also, from a scientific point of view, it's a very bizarre claim, and it doesn't really help the story that much because, well, first of all, there is this island of stability. So it's hard to get atoms that are stable that have that many protons in it. But it's theorized that there might be an island of stability around like 120, 130, but we don't know. And so 115 is even, Jeremy points this out that there's research on it before, but I think he is also maybe not specifying that there's also no good reason to think that 115 could be stable. So, and people ended up trying to make it and it wasn't stable. And so it's hard to get actionable insights from these claims. If people have tried to reproduce it and we're not getting anything close that looks anything realistic, then okay, what do we make of this Lazar story? I mean, that's what I appreciate from Jeremy the most is when he just says, look, what actionable insights can we get from his story to help make progress on building UFOs? Like if that's the end goal, what do we do with this information? And it's very difficult to actually use anything he says to help, but I mean, it's also a very difficult problem. So.
Yeah. And it's something that like, it couldn't inspire more people like you or physicists to like try to dive deeper into this problem with gravity and anti-gravity and get more people working on it and experimenting on some of these theories.
Yeah, it could. And yeah, Lazar was inspirational to Jeremy Rys as well.
Right. Oh yeah. Yeah. He was the reason he started.
Exactly. Yeah. And I mean, at the end of the day, I don't know, Lazar doesn't seem like the worst person in the world to me. Like I feel like there are worse people, but I don't know, maybe once again, it's kind of like the UFOs. It's hard to prove or disprove his story, right? And those seem to, for whatever reason, be the most interesting ones. It's the most mysterious. It's in the middle.
Pull up Google. This is interesting. Pull up on Google Putin's anti-gravity planes.
Oh boy,
this is crazy.
Yeah, I didn't even hear about this one. You were mentioning this. I don't know what this is about.
Okay, pull up that video right there, the top one. Is it long?
30 minutes.
Oh God. All right, go back to the article. We're not gonna.
This already looks legit.
Yeah, super legit. Okay, there you go. Try that one. BitShoot. Oh, that's legit site.
Oh, that's how you know.
Yeah, that's how you know it's real, bro. Oh, it's the same video.
So, is there something you remember?
I just thought I saw the headline. I thought, wow, Putin's got anti-gravity planes.
I mean, it's a nice headline. That's for sure.
It is a super good headline.
I want to click on that.
Yeah.
The club. $9.
Oh my God! Join the Prophecy Club for $9.90.
From your credit card, and you can sign really
okay. So much for anti-gravity planes.
I don't know. Yeah, well, it is funny though because there is going back to kind of the free energy and Tesla stuff. There were claims of Russians in the 70s doing some theoretical physics connected to unified field theory and consciousness and relating to torsion. And as far as I can tell, it seems like it's not a good PR move during the Cold War to claim that Russia's figured out a unified field theory.
Right.
So I don't know the validity of those theories either. And probably a lot of those theories were wrong. But I just noticed that there were theories that were published in the West that were very similar or sometimes identical that didn't cite the Russians. And there was also a response in the West to say that those theories were crazy as well. And there's been evidence in the past decades suggesting that a lot of these theories from the 70s aren't as crazy as it seemed. Once again, it goes back to kind of no-go theorems. People said, oh, if you add any types of terms like this, it's going to lead to bad effects that are unphysical because of some math theorem that I put together and I cooked up. And so there was a lot of evidence suggesting that a lot of these exotic theories that that geometry that Eric Weinstein's talking about, torsion, space-time torsion, that stuff, there's this notion of propagating torsion, and the Russians were studying this during the Cold War, and whatever reason, it was a very active area of research in the West from, the 50s to 70s, and eventually, it's very bizarre what happened. This torsion is in string theory, but what they do is they end up saying, at the end of the day, they make this statement: in vacuum, the torsion vanishes. And I'm joking, like they almost put it in capital letters, like there is no torsion in the vacuum. And so they send out this message saying, oh, we don't have the crazy torsion, but it's actually in their math. The string theorists are doing all the rigorous math. It just to study the electron in curved spacetime, you need torsion to minimally couple it to get a good theory that makes sense based on the principles that we currently use. It requires this torsion. Maybe it's not propagating. Maybe it's not a literal wave equation. Maybe it's just inside matter itself. But it seems to be relevant. And what has happened is they say, okay, well, what's the experimental implications? And they say gravity is about looking into the stars. And so they'll run these tests. They'll say, what is the chances of there being torsion? They'll add in all these terms into their theories, put coefficients, and try to see, should the coefficients be 0? Because if the coefficients are 0, then the whole thing cancels out and it's like not real. And so what they find, they look into the stars and they say, this torsion, it shouldn't affect any of the motion of the stars. From the experimental data, it doesn't look like torsion exists, so it's not real. It's not physical. But they're looking in the wrong place because there's work showing how it's actually an internal gravitational symmetry, whereas we currently think that gravity is only an external symmetry. And so that relates to why it's relevant for the stars, things out there. But it turns out this torsion is more relevant for elementary particles, for atoms, inside matter. If you're trying to make a UFO, you're trying to figure out, how do I use materials from the real world and get this space-time curvature, and how do you engineer it to get the desired space-time warping so I can just, rather than moving through space-time, I bend space-time and then just come along for the ride. And so everyone experimentally is looking for torsion in the wrong places, and the nice theories already predict that it's very difficult to experimentally detect this stuff, but it provides theoretical self-consistency in the theories and probably is actually helpful for quantum gravity. But there's this Wikipedia page, I think it's torsion fields, and it says pseudoscience in parentheses.
Really?
So there's a torsion wiki page, and then there's a torsion field pseudoscience page. And it's a very strange thing because they'll say, or sometimes called the axion field, which is studied in string theory. And it's like, wait, so are you saying torsion is crackpot Wikipedia? Is that what you're... I mean, it makes no sense.
Torsion field, oh my God. The fucking title of it is pseudoscience.
So this is what's happening, where basically anyone in academia who doesn't have the time to look into torsion, right? They just heard from someone else. They heard through the grapevine that torsion's crazy, right? Some Russians studied it, and they don't even show like the original dates. They claim that the Russians looked in the 1990s after the Cold War. It's like, no, they were looking at it before that. So yeah, there's a lot of bold claims. There was this Russian who, maybe even in the 50s or 60s, he claimed to detect torsion from the sky and claimed that it moved faster than light. There's a lack of consensus on that. No one seems to agree with that claim. Maybe it's wrong. Maybe this guy Kozyrev, I don't even know if he's mentioned on that page, which shows you that they're kind of withholding it. Maybe he's on there, but basically there's something going on here for quantum gravity, and depending on, there's different theories that you can have with space-time torsion, and some of them have what could be anti-gravity. But just because you can write down a theory that has anti-gravity doesn't mean it describes nature. So that's the challenge. We're trying to figure out what is the good theory. And the problem is, a lot of these theories, some of them a good class of them, they don't predict enough differences from the standard theory for us to tell. But we know that we're starting to study condensed matter systems, which are just like complicated phases of matter in the laboratory. And it hasn't really gotten to the gravitational point yet, but we're starting to understand that there's a lot of exotic phases of matter, nothing to do with gravity. We can make exotic materials or metamaterials, and those maybe there's some way we can optically pump these materials at different frequencies to create resonant states that effectively lead to new quasi-particles. So we're getting better at becoming alchemists of reality to create arbitrary materials. And so once we start doing that, one of the things I've been trying to point out is that once we connect it to gravity, we should be thinking about things like torsion and non-metricity, which is even more exotic. Fortunately, it's so exotic that there's not as much of a taboo, but it is very strange. The properties it has are very difficult to wrap your head around mathematically and physically, so people prefer not to study it. But when you look into the unified field theory, it seems like getting the exotic matter in there, we should at least stay open-minded and say, there's this mathematics, maybe it'll have utility in the future. And so rather than just blindly rejecting all this mathematics, I'm trying to advocate that we at least study it and stay open-minded. We don't know exactly what theory, but maybe someday there's something in a lab that gets measured that we can't describe, and maybe that's when it turns out, oh, we finally found something in the lab that is giving us something that we can't predict. Maybe that's something going on gravitationally. And we know that there's actually, even in chemistry, there's always slight experimental errors in the measurements. And it ultimately relates to quantum mechanics, and it relates to spin. And as I was mentioning, spin is supposed to source torsion, it seems, because it's torquing space-time. So you have matter that's spinning, and it's like torquing space-time with it. And so if we're neglecting that, there's actually someone who worked at Caltech. She didn't mention torsion, but she said that quantum gravity might describe some of these discrepancies in chemistry, which is a little counterintuitive because you'd expect gravity to do with planets. If we can't feel the gravitational forces between you and I, why would something even smaller affect gravity? But it's not because of the mass or the energy, it's the spin. And the spin of an electron, and it's also a spin density. That's the other important. It's the spin divided by the volume. So that's actually what sources torsion.
Right.
And so if you have something that's really small and it's spinning like a particle, then that might actually lead to torsion. So there's actually no reason to expect that a star that's so huge would lead to torsion because it's so big that it's going to have a small spin density.
Right.
So it could turn out that as we start exploring these more exotic metamaterials and try to figure out if we can build anti-gravity craft, maybe some of that gravitational physics will come into play. And the conventional theories, so this one's mostly talking about propagating torsion, which might be crazy. Maybe we don't need maybe we need non-propagating torsion, which is inside matter, and it doesn't propagate into the vacuum of space-time. And so if it's inside matter and we're trying to make matter to warp space-time, maybe we need the mathematics, the geometry to describe how spin is responding, how space-time is responding to spin.
I wanted to talk to you about that guy named Jack Sarfati.
Exactly. That's a good segue. I think his name is even on that Wikipedia page somewhere.
Is he? What does he have to do with this?
Well, he used to study a lot. Well, let's just actually go through his whole story. It's very, very amusing.
Okay.
So he maybe in the 60s or so, maybe 50s or 60s, he was about 12 years old, maybe 13, 12. He gets a call on the phone, and it's this robotic voice in the 60s claiming to be a computer from the future and that he should go and talk to this military guy to get involved in this secret program to study science or something. And so that's just a very strange thing. And so for what he bought that story, it seems. He's saying, he's repeating it to this day. He's very old now. Jack Sarfati, I think he's 88. And so he ended up having this very strange career where he became a scientist, got a PhD, but also ended up having a career where he somehow was funded by these black budget operations. Basically, he would get money wired from some Swiss bank account. I don't understand the details, right? And so it's just this very bizarre character where it's how is he even getting paid in the first place? It's very strange. But they wanted him to figure out consciousness and how it relates to physics. So he was into that, and he got into that. And so he actually has a lot of mathematical chops to some degree and is pretty knowledgeable, but then is going into a lot of these controversial topics. And so a lot of the Russian physicists are interested in his work, whereas in the West, they're saying he's kind of crazy, right? And so there's this funny thing where even Jack is pointing out, look, the U.S. should care more about my work because the Russians do, you know? And so he's in that old mentality where he's trying to get money based on fear of, okay, we need to combat Russia. So, you know, Cold War mentality, give me funding. And it's a different game than it was 50, 40 years ago. But anyway, so now he kind of went back. He was studying torsion at some point. And
so
now,
going back, who did he claim the robot was that called him and told him that? What did it tell him?
It told him to talk to someone in the military to join some program. I always looked at that and thought the most likely choice of who that was the military. That's just me.
Right. And how old was he?
12 or 13 or...
What the fuck?
So it's a very strange story, right? And he believes it for the most part. I mean, he'll admit it's a possibility that it was the military because I asked him once, but...
Oh, you talked to him?
Yeah, I've met him in person once, and he has this infamous email chain where he's actually pretty rude, to be honest.
Really?
So yeah, he's kind of a dick. So he has a huge ego. But he's claiming I have all the UFO stuff figured out. I have the math. I have the theory. He's trying to say we need some huge project from the U.S. to fund him where he would be the leader of the group and he would run everything, right? And so he struggles at...
Sounds like our buddy Greer.
Yeah, exactly. So Jack doesn't always... He's not great at getting collaborators. He pisses a lot of people off. He'll kind of attack them on emails and just say you're stupid and all this and that. So most people just don't want to put up with him either. And so, I don't know, I at least saw that he was interested in some curious things. So I just wanted to... I stay involved in his little email thread just to see what's going on a little bit. So I've just been learning about what his proposal is, and I think he's asking the right questions. Maybe I have slight disagreements now at this point on what he's claiming, but he thinks he can slightly modify general relativity in a way that's productive, that helps describe how you can get efficient anti-gravity. And he claims that metamaterials will be useful, and the To the Stars Academy group with Tom DeLonge and all those other government people, they were looking at metamaterials. They apparently got some sample. I guess Linda Moulton Howe apparently owns this sample that allegedly was recovered from some UFO crash. They did analysis on it, and it seems like some metamaterial, some complex layered structure with something that was engineered. And so he's paying attention to that, and then he's also been thinking about consciousness, and for whatever reason there's this idea that some of these UFOs are conscious craft. I don't know where this is coming from. So a lot of these people that are in this community have this opinion that you'll eventually get machines. I mean, and it's kind of like AI, right? As you make AI, is there a point where AI breaks through and becomes conscious? And we've already seen that with LLMs, not that they're conscious, but there's sort of this breakthrough where...
With what?
With AI and large language models and ChatGPT.
Okay.
Yeah. So we're already seeing it there where you can never really predict exactly the performance that's going to come out of these systems with AI. You kind of have to test it and see what happens. And sometimes you'll make slow and steady progress, and then all of a sudden it just gets way better once you throw more information at it. And that sort of happened with GPT-4. So maybe you could argue that if you brought quantum computing in with AI,
right,
that could lead to machines that are conscious, and maybe that machine could also be an anti-gravity craft that is conscious. And people claim a lot of these, I don't know what to think of any of this information. People who claim to get abducted seem to say that people interact with the craft telepathically.
Right. And with the beings in the craft.
Yeah, exactly.
Like there's that whole abduction phenomenon where there's tons of people, that guy John Mack, that Harvard psychiatrist or psychologist, studied all those people. You familiar with that?
No, I'm not.
Okay, yeah, that's basically what you're saying.
Nice, interesting.
Yeah.
Yeah, so it sounds like some crazy ideas, but even the Nobel laureate Roger Penrose, has some ideas with Hameroff on how consciousness works and how it relates to quantum mechanics and how it might be related to things in our brain that are sort of like metamaterials. And so Jack has kind of keyed into that as well. And so there's something bizarre happening where the claimed resonant frequency of these metamaterials from these craft are in the terahertz regime. When Tom DeLonge was on...
terahertz regime?
It's a frequency range of light. So think of different colors as different frequencies.
Got it.
Yeah, many people just, they're oh yeah, terahertz waves. It's like, what is that, right? It's just electromagnetic waves in a certain frequency range.
Got it.
And so it seems like these metamaterials, there was some analysis apparently done suggesting that something in the terahertz regime, that's why Tom DeLonge was talking about it, because of that. And then it seems
What did Tom DeLonge say about it?
The materials that his To the Stars Academy group looked at seemed to respond positively, to have an effect, work with, if you pump it with high frequency light, you can maybe get some exotic effects coming out, is the idea. And also in the brain, there's arguments claiming that maybe there's some, I'm getting this from Jack Sarfati, and I don't know if it's true or anything, but he's claiming that he sees the connection between consciousness in our brain and these materials. And he also claims that he has a theory to see why those materials would lead to anti-gravity. But all of that should be questioned. No one else in the world would really claim that that is true. That's his claim. And I think maybe he's on the right track, but I don't think he has all the details figured out, but it's curious.
So what is his overall like 30,000 foot opinion on what like the modern day UFOs are that we're seeing, that the Navy pilots are seeing?
Well, he's just basically trying to point out that we do have the theory to predict it. He's saying it doesn't violate the laws of physics.
Okay. And
he's claiming that he has the understanding on how to run a group to actually make these. Because most people are dumbfounded on trying to describe it for the most part. So at least he's attempting it, but it's a work in progress, like everything. Most people aren't going to get it right at first.
How come all these crazy people, like these geniuses, like this guy, like this Sarfati guy, or like Robert Bigelow, all these people have these crazy, wacky stories of like why they're preordained to be the fucking savior of the world. A robot called me and told me to contact the military.
It's so strange, right?
I mean, no offense to the guy who runs your company, but like my son can remote view. Like it's me, my personal bias, like thinks like, why do you have to throw this in? Like it just seems so bizarre and outlandish to me.
Yeah.
That your son can remote. I figured out my son can. How do you figure that out? It blows my mind. But yet these people are super fucking smart. This dude's a billionaire who's throwing millions and millions of dollars into people like you to research these theories, which is amazing. Like it's just like it's interesting. I've noticed just a correlation into people like that have these weird sort of like stories.
Ultimately,
like origin stories. Almost.
Yeah, it's about people's experiences, right? And whether you believe, how you interpret those experiences. Everyone is coming from a different background in life, and that's why some things seem realistic to some people and other things don't. Like if you never see any weird things happen, you think the world isn't weird, you know?
Yeah.
And you just go to your desk every day, push some numbers, whatever. There's nothing weird happening. Why would there be remote viewing or this and that? But if you're going through your life day to day and you're seeing things frequently, you have to rationally find some way to explain it. And once you go through all the options and nothing's left, and it starts to get to a point where once you have weird experiences, it's hard to not come up with a weird explanation.
Yeah, and it's always like those weird experiences almost inspire these people to take on these tasks. You know what I mean?
Right, exactly, because that's what forms their opinion that it's even possible in the first place, right?
Like, I don't know how familiar you are with that guy Bob Bigelow who has that aerospace company, but he talked about having like wild experiences with like poltergeists in his house.
It's very strange.
like seeing entities or hearing like, interacting with ghosts and shit. Like,
Yeah,
and
I don't know what to
remote
make of all of it.
viewing, and like, I don't know what to make of it either. And like psychic abilities.
I just try to not accept or deny it. I just try to take it in, remember it, and say it's a possibility. I don't know. Because at the end of the day, it's very easy to just get a knee-jerk reaction to either accept or deny something, right? We want to believe these UFOs are real, but then other crazy things, we might not want to believe it, right? Maybe remote viewing is possible, but UFOs that don't exist. I don't know. You know, you never know. It's hard to know. I mean, that's what I struggle with. I don't feel like I know anything, actually, when I think about what it actually means to know something. I might think I know something, but I don't know.
You could have a better understanding of it. Like you could have a comparatively better understanding of it than other people, or like than most people. Like you could have done like the work to understand it enough to talk about it and have like an intelligent debate or conversation about it to where you can understand it more, but you still don't know it all.
And all those descriptions are just approximations.
Yeah, right, exactly.
So they're not right.
Yes. You know, and then there's also like what we were talking about last night when it comes to like some of these crazy abilities that people like the remote viewing and seeing ghosts or seeing spaceships. People that, like, there's so many people that claim they're abducted by aliens or that see UFOs or had like things appear in their rooms. And like I told you, that Gary Nolan, the guy who studied all those metamaterials, Gary Nolan is, pull up his Wikipedia page. I forget what his exact title is, but he basically found these metamaterials or these materials from an excavated UFO crash site in New Mexico. There he is. He's a immunologist and an inventor. But he works really closely with that guy Jacques Vallée.
Okay, yeah, right.
And studying some of these materials, they found that they're basically like they're unexplainable to our modern science or technology.
So we're starting to understand the science of it. We are. It's just very advanced, and we don't understand everything about it, but we're starting to get our toes wet, so to speak. And we are producing exotic materials in the lab. And that's why overall, like I grew up in particle physics, but that whole field is dying because the LHC has kind of discovered what it needed to discover. But the real big field of physics is condensed matter. And that's all about studying things like metamaterials. So vast majority of physics is going in that direction of studying real materials. And that's very active area of research. We're discovering all the time tons of papers of new exotic phases of matter. And that's the thing. No one knows exactly how they'll be useful yet. And so it's really mind blowing, because if you think about atoms, there's only about 100 different types of atoms, and we can combine those atoms to make molecules, but it's a finite number.
Right.
The thing that is so mind-blowing about these different exotic phases of matter is that it's like there's effectively an infinite number of atoms, because as soon as you pump with one type of wave at some frequency and you have some type of setup, sometimes you can get these exotic phases where the particle gets dressed by some other fields and gets this new identity. And it becomes some quasi-particle with different properties. And so it's like you can make, in the lab, you can simulate new particles effectively, where really it's all this chaotic stuff going on, but you can find this theory that says effectively it's roughly like there's just this quasi-particle that, and then it makes it simpler to work with these quasi-particles. But really maybe it's just a model for what's happening, and it's pretty accurate at describing what's happening. And so we don't understand yet the full landscape. There is some classifications on types of materials you can make, and that's been progress that's happening, but I don't think we understand fully yet all the different types of quasi-particles we can make.
Right.
And so that's why I think it's so exciting to see what's happening in science right now, because we see it, right? We're waiting for that Jetsons moment where we can just finally take off into the sky, and we're starting to see the scientists latch onto all these new types of materials and study in the conventional laboratory setting. They're not thinking about anti-gravity right now, but who knows what'll happen in 20 years once it starts to find new applications. Maybe it doesn't get used right away for one thing, it gets used for another thing. Once it starts making it in the industry, then you start making cheap copies, you start producing it on a mass scale, then more people start playing with these exotic materials. Then you got some crazy tinkerer who says, wait, if I combine these three things in a clever way, maybe that can lead to some novel device, you know?
Mm-hmm.
So it'll take a little time to get there, but we're making progress.
It's interesting too, the metamaterials that a lot of people describe from various quote unquote crash sites around the world, like New Mexico and like Roswell and even Brazil, in Varginha, Brazil, there was that crash that James Fox made the documentary about. They all describe this material as being like this foil shape material, like a very thin metal, lightweight foil that they can crumple up in their hands. And as soon as they let go of it, it takes shape again. It's interesting that it's very like everybody describes it like that.
Yeah, it is strange, right?
Mm-hmm.
I don't know if that means, you'd think it means there's more likely or something there, but I don't know. But yeah, it also makes sense that you would want to engineer a material like that. Mm-hmm. You want something that's strong and super light and a metal that's really thin for aerospace, and that makes a lot of sense that you would find something like that.
Right.
If there was some advanced technology.
We talked a little bit last night about Stephen Greer.
Yeah, he's a character.
You watched his documentaries and stuff?
Yeah, I actually met him in person once and talked to him for about 5 minutes.
What got you interested in him?
Well, once again, it was this type of thing where I originally was just trying to figure out efficient engine technology based on quantum field theory and to just see if quantum field theory could help. And that led into finding more free energy stuff. And once you start looking on the internet obsessively, you just start running into people. And at first you ignore it. I don't care about UFOs. He's got all this other stuff he's talking about. But then eventually, honestly, the idea of what he did with the Disclosure Project, when I heard about that, it kind of blew my mind in a way. I mean, he seems to be doing something that is risky. He is collecting all these documents that are claimed to be classified documents that he's getting from these whistleblowers. And so he, in some ways, has this underground community as being a pioneer with bringing whistleblowers out to the public since 2000. And so that part of his story really caught my attention because it's hard to imagine why someone would take such a risk. It seemed like he was doing this out of the goodness of his own heart to some degree. It seemed like he has this passion, this deep passion to explore this problem. Like, it's just very difficult to go through the daily motions if you don't actually care about this stuff, right? So it seems like he does care. He puts on a good show at least, right? And so that's what caught my attention. It was just strange. I didn't know what to think of it for the longest time. So he basically is trying to say that there's all of this technology that's in the private sector that has been reverse engineered, including applications for UFOs, but also free energy and medical technology. And so he's claiming that a large reason why we don't, or why the military is, or not even the military, these private companies, these aerospace companies might be holding this technology back is because of how the economy works. And there's this idea that if you put a product on the market that's so disruptive, it will destroy the economy. So there's this other guy that I met once named Nassim Haramein. He's this controversial figure who's kind of an outsider to the science community, but is a scientist, so he claims, and does research and has this institute and looks into exotic technology. I talked to him. It's funny. They claim they have figured out some stuff. When I asked him, well, why haven't you released it? He said, I didn't realize this, but someone told me that if I did, it would destroy the economy, and I don't want to do that.
How would it destroy the economy?
Because then
people wouldn't buy cars anymore?
Yeah, well, then oil gets shut down, and then that's connected to geopolitical implications, and then think about all the people who have jobs but I don't know. So I've noticed this thing where it seems to me that someone told him that. And I also know that he seemed to get investment. Well, I think he got investment money. So I don't know. It seems like there's something.
Greer did?
No.
no.
Nassim Haramein.
Okay.
So it seems like something is happening where people with money are giving money to people who are inventors and saying, hey, you should be careful about putting this out because you want to do good in the world, but hey, I want to do good in the world too. But you're actually going to destroy the economy if you put this out too fast. because it'll be too disruptive, right? And it kind of makes sense in some regards in terms of innovation. Like, you don't want to innovate too fast. There's not, if you're making a new iPhone, and then a day later you make one that's infinitely better, and then a day later you make one that's even better,
right?
You can't distribute it out in the world quick enough. So there's this debate on, let's just say there was this godlike technology that solved all of our problems, right? There's this debate on what is the safest way to bring that technology out. Some people say that it's safest, right? Because if you do something too chaotic, it'll cause a shock to the system, is the argument. I don't really believe that.
Right, but like,
people make that argument.
Let's just say that one of these people had figured out anti-gravity, right? Figure out how to have transportation not be combustion engines, right? We can basically to propel ourselves around the world and the universe with anti-gravity. Okay, it's if they let the cat out of the bag, all of the companies that are creating airplanes or cars or whatever it is, they would all have to start developing it and commercializing it at the same time. They would all start in the same place. People wouldn't instantly be able to go out and buy these things. It would be a slow, like a bad analogy to this would be like Elon Musk talking about building these like a new version of his car. Like, he announces some new Tesla car that's crazy fast, or like the Tesla truck he announced like 4 years ago, and it's still not out yet. And there's all these companies that are talking about like this new technology that they're working on developing. It doesn't come out, people know about it, but like everyone has to catch up slowly until it becomes available to the market, and then eventually like saturates the market. So like, I get the idea, but it's not like something is going to be instantly everyone's going to buy it and put everybody out of business.
I agree with you.
Still, everyone's going to have to buy regular cars and fly regular airplanes for the next 10, 20 years.
Yeah, and there would be a transition. It would take time. It's not going to be that catastrophic. But another way to look at it is, if you were an aerospace company and you did have advanced technology, do you let go of your biggest secrets right away, or do you just make a plane that's slightly better than the last version that's already in the public? Which is going to make you more money, right? Are you going to make more money by just releasing your best technology out now? Or are you going to make more money by taking 100 years to releasing it and slowly iterating, putting out slightly better plane, make money there, slightly better plane, make money there, slightly better plane, right? You never get to what you actually have. And that way it provides security as well, because if these companies are doing contracting for the military, you want to stay ahead of the game. So, right, the U.S. is trading weapons. The U.S. wants to keep the best weapons for themselves just in case something bad happens, right?
Right.
So you want to stockpile your best technology. It just makes a lot of sense from a military perspective and a financial perspective, because if you have a secret that no one else knows, you can do something that's worse than that secret and put that out and iterate on that and just climb a ladder. If you just put it out right away, yeah, you might get a bunch of money really quickly, but it might not be as long-term of a strategy to make more money.
Right.
And it provides that security of, you can drip out technology that you have something better than. And so now, the Russians or whoever, they're looking at what's out there in the public and they're reverse engineering our weapons to make, but it's like, if we're already ahead of what's out there and they're taking time to catch up what we released, they're already advancing further.
Right.
And so they can stay ahead of the game. And so it does make sense to me that obviously some technology comes out of the military at times, and sometimes stuff stays classified. I mean, that's not a controversial statement, right?
No.
So, but it's surprising to me that more academics don't realize this or think about this, the fact that it's obvious that there are secrets. And I think academics maybe get a slight ego that thinking, they're the smart guys, so it's not possible for someone in the private sector to actually discover something new in science if it's just one person. It seems much easier if you're open in the public and you have a team of scientists who are the smartest people in the world. Like, wouldn't they figure out all the advanced things? But are they thinking of theories? Or are they tinkering on how to make anti-gravity craft? Like, if that's your end goal, you kind of need to be doing that to make progress with it. So obviously the aerospace industry would have a leg up on figuring out novel propulsion.
It makes you think of the quantum computer too. Like, have you seen photos of that big IBM quantum computer they're building with like all those fans, a giant pyramid of fans? Things fucking insane looking. And Michio Kaku said that thing's going to make us immortal.
Maybe. Will it make us immortal? I don't know.
How long do you think before? How long do you think before quantum computers become a thing that everyone has access to?
Oh, everyone has access.
Oh yeah, there's a picture. Maybe not everyone, but maybe like before it becomes like a thing that like maybe like the biggest companies have.
I would say 5 to 10 years. There's going to be more breakthroughs.
And what is that thing right there supposed to do?
Well, I suppose it's supposed to be a quantum computer. So essentially, classical computers have bits, zeros and ones.
And this thing operates on atoms.
This uses qubits, which are these quantum states that have the probability of being alive and dead. They can be 0 and 1 at the same time.
Right.
So it's just a fundamentally different paradigm of computation. And really what it is it gives you different ways to solve problems than classical computers. And a lot of those ways seem to be useful. But so there's this catch-up. There are certain things that right now classical computers are better at. And so there are quantum computers that exist, but they're not great yet. They're not competitive. So they're just starting to put out papers where they'll pick a very specific problem that they fine-tune, that they know the quantum computer will be good at. It's not really a useful problem, but it's just something they can compute to get some data for. And then they'll show, hey, if we do this very specific thing, the quantum computer is better at that thing that isn't really useful yet. But it's progress. And so eventually the thought is once you get the quantum computers better and better, there's a lot of errors. It's hard to make a good one. It's very difficult. There's a lot of noise involved. And so once they reduce all that noise and can get a clean quantum computer, then the hope is that it should be able to outperform classical computers, or at least solve certain problems that classical computers would be bad at solving. And then maybe eventually also be able to do everything a classical computer could do. But who knows? There might be some stuff where sometimes classical computers could still have some utility as well. And you could just use both. It's just another tool in the toolbox. And so I would say that we're at this point where it's experimentally realized, it's entering industry, companies are being formed, there's investment money, and it's just getting there. It's just getting there. Right. So I would say 5 years is where it's going to start taking off.
Do you ever think about like what the implications would be on humanity when this sort of stuff becomes real and we start using it for different applications, whether it be like commercial stuff or medicine or
it will help
communication,
find solutions to arbitrary problems. It's so vast on what computers have been useful for, right? So just think of a better computer. The sky is the limit. And especially also it's just really interesting to see the development of AI at the same time. And so I think the huge explosion is going to be once AI gets into quantum computers, you're going to get best of both worlds, and that's going to lead to some revolutionary things.
That's the singularity. That's where we become slaves to the robots.
We'll see what happens, right? Or do we merge with them, or do we figure out how to unplug their power if we need to? I mean, it's all about how you look at it. I mean, the unknown is always scary. And so I like to just think that at the end of the day, if most people try to make good decisions, then hopefully it'll work out. But it is hard to trust humanity at times. But I think humanity is doing a lot better than our society likes to give ourselves credit. I think we're going through this self-reflection period, which is healthy. So I think humanity is doing a lot of reflecting on all the negative aspects to try to understand how we can improve. And I think that's healthy, right? Before there was the internet, you just read what was in the newspaper and it was hard to get information. So as soon as all this information was easily accessible, that's what caused us to reflect and think deeply about, wait, humanity's doing this, we're doing that. I didn't know that, right? And we're learning all these new things that we have access to, and we're uncomfortable with it. We don't feel like we're going in the best direction. It's a little nerve-wracking. Maybe we'll destroy our planet with global warming, this and that. But I think we do have the technology to solve these problems. I think we can solve these things. And as soon as we actually need to solve them, I think we will find creative solutions. And so you can get excited or you can get fearful. I think we should get a mix of both, and we should just be responsible and try to do the best and make advancements that, to me, I think it's key to try to focus on technology that frees us. We don't want to get a system where we become too dependent on it, because then that will lead us to becoming weaker over time. But it's going to happen to some degree. I think it's hard to get around that, right? Like, once you have robots that can do everyone's jobs, it's going to be a rocky transition to there. I mean, maybe it doesn't happen that way, literally. But let's say it did happen. What happens 500 years in the future? How are you even motivated to do anything if it's just you push a button and it does everything for you? It might change our psychology where we sort of get lazier.
Or maybe it like frees up time for us to not do like monotonous, busy stuff.
Hopefully.
We become more creative. Figure out a way to become one of those type 2 civilizations or type 1 civilization.
Yeah, so I think both is going to happen.
Just like these warring apes trying to blow each other up.
Yeah, I don't think it's going to literally be idiocracy level, but I think on average, we won't need every person to contribute as much as we used to. So that will change things, but that'll lead to more freedom of exploration, which will drive curiosity, drive creativity.
Yeah.
And I think that's the thing to focus on, is the potential for additional freedom. But, right, how do we not get stuck in some economic system that ends up turning into some pseudo-communistic state? You know, a lot of the AI advocates are saying we need universal basic income. I don't understand how that's going to work right away, especially if it's not done internationally. How do you realistically do that? Especially the US, we're exporting dollars. You just start printing money and giving it out to the citizens.
Right.
Why would anyone want to hold on to dollars? Well, we're going to need a new financial system. We change our financial system in the US roughly every 40 years. We went off the gold standard.
Right.
We confiscated everyone's gold during the Great Depression.
Right.
We change things about every 40 years. So we're kind of due for some financial change, and we're going to have to figure that out.
Where do you think that goes next?
I don't know. I mean, there's all this talk of digital currencies, right? Is it fully decentralized? The Bitcoin versus the central banks, they're making their digital currencies. What's that going to lead to? Obviously, we don't want to go into the full China mode.
Right. That's
and
fucking
so it's nerve-wracking.
Shit,
yeah.
Huh? Minority Report.
Yeah. And so it's nerve-wracking, right? You can imagine it going really good or really bad.
Yeah.
And realistically, it's probably going to end up somewhere in the middle.
Yeah. How did you meet Jeremy Rys? Did he reach out to you?
You know, it was through this APEC community. I had been aware of his YouTube channel for a while and had been watching some of it. And then it was actually through Jack Sarfati's email list that they wanted Jack to give a talk, and Jack didn't want to give one. So then I ended up giving a talk to their conference.
Why didn't you want to talk?
He thought they weren't serious enough.
Oh, wow.
Because he's this highbrow academic.
Yeah.
So, yeah. There's this group, Falcon Space or something like this, and they have some lab where they're doing a bunch of experiments, and there's debates there because the experimentalists there they don't care about general relativity, which is our theory of gravity. So Jack sees that as being disrespectful to some degree. So yeah, I don't know. We'll see what ends up happening with all
so
the
what is
stuff
going
they're
on
trying.
with the APEC conference thing?
Yeah, so I mean, it's just this community where they have a bunch of people giving talks, and there is this lab that's sort of adjacent to it where a lot of the lab members will give talks there, and then they'll also invite other guests to share ideas. They're trying to go for this sort of open source movement and try to figure out, I guess, anomalous propulsion. Originally they started calling it anti-gravity, but then, so that's the other thing. There's a debate on what anti-gravity is, right? Some people latch onto that term and then start doing things that might just be electromagnetic, but maybe there's some efficient way to get propulsion that technically isn't anti-gravity, but is still helpful.
Right.
So then some people are saying, I'm only interested in the true anti-gravity, the warp space where I can go to other galaxies. Other people are saying, well, I'm in a lab tinkering. I just want to figure out how to get to outer space most efficiently. Maybe the most efficient way to get out of our atmosphere is different than the most efficient way to travel in space. And so there might actually be a couple different types of technologies that get developed. And sometimes people don't realize that difference. So then there's like debates.
Right.
And that happens on this email thread a lot.
So going back to our discussion earlier about like dark government programs working on like super advanced technology they wouldn't want to get out to the mainstream because it would disrupt the economy or disrupt some like big industries like oil or whatever it might be. I was mentioning to you yesterday that guy Malcolm Bendall who has the plasmoid technology. Can you Google that guy's name, Malcolm Bendall, so we can actually read the real description of it? But I was telling you, like Shell Oil he got into a big. So type in Malcolm Bendall Shell Oil, and we can like see what's happening. But it sounds like he's discovered some sort of technology, atomic energy from water plasmoid, protium power for internal combustion engines using water as an atomic fuel. So go to that first paragraph of that second page. Zoom in on that.
That sounds like some electrolysis, perhaps.
The implosive energy revolution of the thunderstorm generator. Australian Malcolm Bendall has invented a proprietary plasmoid-induced and controlled atomic energy release process, which allows water to be used as atomic fuel. When deployed as an engine, the Bendall engine, this innovation is known as the thunderstorm generator. Using this novel technology, conventional engines and generators can be retrofitted to run on a combustion of water as fossil fuels, producing negligible toxic emissions when compared to current outputs. Existing hydrocarbon fossil fuels, petrol, diesel, and gas are solely used to achieve the initial operating temperatures and vacuum. Anyways, this is fucking some wild shit that he's come up with.
Yeah, this sounds like a lot of people would initially reject this.
Yeah, and there was
wild.
Apparently there was some big fight between him and Shell Oil where he was I forget what exactly he was doing. I think he was buying land like way back in the day to like sort of excavate oil or to like pull oil out of it. And he was doing some work with Shell, and then he came out with this, and then Shell, I guess they got intimidated by this and they wanted to suppress it. So they came out with some like disinformation about him and published it. So where people wouldn't take him seriously. But this is the guy, he went on Joe Rogan's podcast with this guy, Randall Carlson, and they never released the episode.
I will say that there are a lot of similar sounding claims out there of a lot of people trying to use water to split hydrogen and oxygen away from each other and use that for engines. And there's a lot of different designs claiming to do this, but there's kind of this mainstream thought that allows people to just say that makes no sense. There's no way that this could all work. I don't know. I don't know what to think of it.
Who was the guy who there was a guy who like got poisoned or something? The guy who got
Stanley Meyer.
He
also claimed to have a water powered car. And there's a lot of YouTube videos of people claiming to have water powered cars. Usually they can't go that fast, maybe like 30 miles per hour. I don't know. I've never drove one in person and inspected it, but it's a little curious to me that there's possibility that all of them are fake, but it's something to keep in mind. Well, are there a lot of tinkers that are actually figuring this out or not? I don't know.
Right.
Something to keep in mind. Yeah, it's very, and Stephen Greer claims that the people who got access to this patent once Stanley Meyer died, he claims that entire board of directors also got killed besides one person who then was scared to do anything.
The board of directors for what?
There was some company that apparently owned these patents that Stanley Meyer had. So Stanley Meyer died, and then the ownership of the patents went to someone else. Is what I heard from Stephen Greer.
Maybe like search Stanley Meyer patent owners.
And this is a
Death.
thing I haven't. It's hard to find that information on the internet. Stephen Greer is claiming that he knows about this because he tried buying the patents himself.
Oh, really?
So he was trying to get a hold of these patents, and he wanted to pay money to open source it, is what he claims. He claimed he wanted to give millions of dollars to release the patents.
Who claimed this?
Stephen Greer.
Okay.
I don't know. And so that's what he claims. And then he claims that all the people who owned it, besides one person, got killed. And there's also claims that one of the patents had errors in it. I don't know. It's a huge mess.
A lot of claims.
Yeah, exactly. I keep saying that because I don't know. At the end of the day, I don't know. But it just strikes me as bizarre that there are a lot of people claiming to have water-powered cars. I don't know if it is possible or not, but it seems like it could be possible. It's all about the efficiency. It is possible. It's all about the efficiency.
Right.
And people are saying it shouldn't be this efficient. It shouldn't be possible to make it that efficient.
Right.
And there's even claims of water having this fourth state of matter. It's probably not relevant in here, in biological applications as well. So there are things that maybe we don't understand about water yet. There's controversial things, but the scientists, they're always assuming that their understanding is reality. Their best understanding is reality, but there's always mysteries. And so that's why I think you do have to be open-minded. But yeah, I mean, you don't want to just get blindly excited by bold claims either. So yeah, it is. I find it curious, all these types of things.
Yeah. Well, David, you got a plane to catch.
All right.
Thanks for doing this, man. This
Thanks so much.
was fascinating. You shattered my brain during this conversation. Tell people that are watching and listening where they can find more of the stuff that you're doing, like people you're working with, where they can follow you guys and all that.
Yeah, they can follow us on YouTube at Quantum Gravity Research. We also have a website, quantumgravityresearch.org, and you can see what type of work we're doing and follow up. We'll be doing more explainer videos and starting to make more content as well. So
hell yeah.
For that.
Cool. Well, I'll link everything below in the description. And sleep tight, everybody.